Hi friends, it's Miss Havi. I'm here at the Haiku Elementary School garden, and I am so excited to talk to you today about my very favorite thing. Now, maybe you're wondering, her very favorite thing, I bet it's a plant, or I bet it's a kind of flower. And while I do definitely have my favorite kinds of plants and flowers, my very favorite thing in the garden is the soil. Is that weird? You're thinking, yeah, that's a little strange. But if you don't have healthy soil, then you can't have healthy plants. So soil is where it all starts. And I want to talk to you today about what soil is. We know that it's under our feet as we're playing outside, or maybe we've seen it before as we've been planting something in the garden. But have you really stopped to think about what makes soil? Where does it come from? So we're going to talk about that today. So we want to talk about what soil is. What makes soil? Where does it come from? What are the ingredients of soil? And the thing is, do you think that soil is the same everywhere on the planet? No. You won't find the same soil on the mainland as you would here, or in Russia, or China, or even from Haiku to Kula to Kihei. There's so many different kinds of soil, but there are 4 main ingredients of soil. And those 4 ingredients are minerals, water, air, and organic matter. Minerals make up almost half, about 45% of soil. So where do minerals come from? What are minerals? Minerals come from broken down rock. So think about all the different rocks in the world, and through things like wind and water and lightning and freezing and thawing. This happens through a process that we call weathering and erosion. It breaks down those rock particles into tiny, tiny little pieces that deposit themselves down on the ground and become part of our soil. So now there's water and air, and each one of those is about 25% of our soil. So we've got 45% mineral, 25% water, 25% air. So let's add that up. 45 plus 25 is 70, and then another 25 is 95, so that's only 95%. What's the other 5%? That's organic matter. When we talk about organic matter, those are things that were once alive that are now dead. So trees that were once living, but now the leaves have fallen off and they're dying, or the sticks or branches that are now on the ground and dying, or grass that's been clipped and it's been cut and now it's dead. Even things like animals, old plants that have died, things that were once alive that have now died, that are decomposing or breaking down. Those things are organic matter. And we're going to talk in another lesson about organic matter and how it breaks down through the system of composting. Also super cool. But today, just so you can review what soil is made of, there's 4 ingredients. Do you remember what they are? Minerals, water, air, and organic matter. 45% mineral, 25% water, 25% air, and 5% organic matter. We're going to talk more about that coming up, and I'm going to show you some examples of different kinds of soil. So even though they all have those 4 ingredients, they have different levels of different minerals and different qualities to them. So we're going to go over that next. Okay, so now you know that soil has minerals. And minerals come from what? Broken down rock. That's right. And as rocks break down and they release those minerals into the soil, we're going to find that soil in different areas of the world will be different because of the types of rocks that have broken down to create that soil. Here in Hawaii, we have a very interesting kind of rock that breaks down. Can you guys think of what we might have here that maybe other places in the world don't have a lot of? Volcanoes. So we have volcanic rock that breaks down, which is really cool because we have a unique kind of soil here that you can't find in other places in the world. So now that we know that there are minerals and that they come from different kinds of rock, there are 3 different types that we need to know. And those types are sand, silt, and clay. And sand, silt, and clay all hold moisture and water differently. So let's think about sand. We've all been to the beach and we've taken a handful of sand. And if I had a big handful of sand and I poured water into it, what happens? It just drains right through, right? The sand doesn't hold the water, it just drains through. But if you guys have ever played with clay, or if you live in an area like the North Shore or Haiku, where the soil has a lot of clay, when it gets wet, what happens? It gets sticky, it sticks together and it holds all that moisture and it turns into like a big moldable clump. So if I were to plant a plant, would I want to put it in the sand where all the water was just going to drain away? No, because the roots wouldn't be able to drink up any of that water. But would I also want to plant a plant in just clay where it has too much water and those roots would probably get too soggy and drown? No, I don't want to do that either. So I want to find a soil that has a good balance of a little bit of sand, some clay, and also silt. Silt is the one that is kind of hard to find if you're just looking with your hands, but it is in there and it's the middle between sand and clay. So sand particles are round under a microscope and they're heavier. Silt particles are square under a microscope and they're about medium weight. And then clay are really thin, like sheets of paper, really thin, and they're lightest, so they're going to be the lightest weight. So how you can tell how much sand, silt, and clay you have in your soil at home, we're going to do some really cool activities where we're going to take soil into a jar, add some water to it, and just shake it up really, really well. Just shake it with water. And then what's going to happen if the sand is the heaviest? Where is the sand going to go? That's right, it'll go to the bottom. And then since the silt is the medium weight, where will it go? Right on top of the sand. And clay, since it's the lightest, then it's going to go right on top of the silt. So if I take a jar of soil and I shake it up like that with water, it's going to settle and it's going to show me at the bottom how much sand, then how much silt, then how much clay. And then you're going to see floating on the top a lot of that organic matter, things that haven't yet broken down, like sticks and twigs and dead leaves, that kind of thing. So this is an awesome way for you to say, oh my gosh, my soil has more sand, or my soil has more clay, and you can compare it with your friends. So we're going to show you how to do what we call the shake jar test. That's coming up next. Okay, so I've gone out in the garden and I've collected some soil into a clear glass jar. You can also use plastic as long as it's clear and you can see through it. So I've gone out and collected this awesome sample. And I got this out of one of my garden beds. So this is going to tell me what the soil, how much sand, silt, and clay, and maybe how much organic matter is in that soil. So you'll take your jar and fill it up about halfway with soil. And then all you have to do is take some water, pour it in. Leave some room at the top though, because you do want a little bit of room to shake it up. I'm going to put the lid on. This is my favorite part. Now you just got to shake it. Shake it, shake it, shake it. And you can pass it around to your brothers and sisters or parents or aunties or uncles and have them shake it too. And you want to shake it really, 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 really good to get all those particles mixed up. And then you let it sit. And you want to let it sit for at least a couple of hours, but even better, overnight. And then tomorrow morning, you'll be able to look at it and see how it's separated. But even just now, if I take a look at what's going on in here, I can already see that those sand particles, the heavy particles, are going towards the bottom. But right now, the rest of the water looks really muddy because I just shook it up. But by morning, the top should be clear, and then you'll be able to see at the very top, there's going to be a very light layer of clay, a sort of grayish looking layer of silt, and then you're going to have your big particle pieces of sand. And again, floating on the top, what will I find floating on the top? My organic matter, my things that were once alive that are now dead, that are decomposing, like leaves and sticks and other, things from other plants. Or in here, I'm trying to see what I've got. I've got some really fun things. I've got definitely some sticks and some pieces of leaves, and yeah, it's really fun to see what ends up in there. So I'm already being able to see what's going on here with my soil. And do you think that each one of you, if you do this at home, that you'll have the same exact type of soil? No way. And some of you will see that your soil is darker, some will see that it's lighter, and that all has to do with what's going on with those minerals and what's making up that soil. So if I took this jar and I shook it up and it was just almost all sand, then I'm going to think, that's not very balanced. I better add to my soil to give it a little more clay, or to add a little more organic matter if there's not any organic matter floating on the top. So we're going to talk a little bit more in a later lesson about compost and adding compost to your soil to make sure that it has a good balance. But this activity is so much fun, and I can't wait to see what your soil looks like once you do this.